Problem 10. I need to find out value of this load resistance to get maximum power at load, and also I need to calculate the value of maximum power at load. I am following maximum power transfer theorem. This is main circuit. So first I need to find out open circuit voltage. So load resistance is removed. See here, load resistance has been removed. Rest part of the circuit is same. So I need to find out this VOC, open circuit voltage. This VOC is potential at this point with respect to this point. No current is flowing through this 2 ohm resistance, so potential at this point is equal to potential at this point. So VOC is potential at this point with respect to this point. What is that? It is just a potential drop across this 6 ohm resistance. So to find out potential across this 6 ohm resistance, I need to know the value of current flowing through this 6 ohm resistance. That current multiplied by this 6 ohm is the potential drop across this 6 ohm resistance. Now what is this current? This current will flow because of only this source, that is 12 volt, and the current will flow through this path. So value of resistance will be full path resistance, that is 12 plus 6 ohm. So ultimately this 12 volt divided by 12 plus 6 ohm, this is the current flowing through this 6 ohm resistance. That current multiplied by this 6 ohm is ultimately VOC, and we got 4 volt, which is the value of open circuit voltage. Now we need to calculate RTH. So open this load resistance here, and sources will be replaced by their internal resistances. So this will be shorted here. So this is circuit for calculating RTH. It is very easy that this 12 and 6 are in parallel, and equivalent of this are in series with 2. So 12 and 6 are in parallel, equivalent of this will be added with this 2. Ultimately RTH I got 6 ohm. So this is the equivalent Thevenin circuit. VTH is 4 volt, RTH is 6 ohm. Load resistance will be same as RTH to get the maximum power at load. Value of RL is 6 ohm. By putting the value in the formula to get maximum power, I got maximum power is 0.67 watt. Now checking whether my calculation is perfect or not. This is the equivalent circuit. 4 volt is the Thevenin voltage, 6 ohm Thevenin resistance, and load resistance is equal to same as Thevenin resistance, which is 6 ohm, and in main circuit the load resistance I have used at 6 ohm. Now power at load in main circuit and power at load in equivalent circuit, if these two are same, then we can ascertain that my calculation is perfect, and power at this wattmeter should be 0.67 watt. Now running the simulation, say in equivalent circuit power at load is showing 0.67 watt. In main circuit also power at load it is showing 0.67 watt. So my calculation is perfect.